So I've had multiple people reach out to me and ask how I'm getting my saw to run so fast. I wanted to walk out here and show you guys a couple of things to check, and then also one of the issues I just had in the last week that took me a minute to figure out, but I just had to watch the meal, and I want to show you guys this so you can check your stuff and possibly help you to be able to saw faster. If you're someone who has put new guide rollers on, new blade wheel belts, you've got proper tension, your blade is tracking good, you've got the proper airbag tension, you've got a new belt on the motor, you've basically went through everything on the mill, and you have, got it dialed in to where it should cut right. But then you go to cut and you get it in material that is, 14 to 25 inches thick, and then you're having belt squilling issues. And what I mean is your belt is squilling before your motor is ever bogging down. The thing about these mills, and just like the test that Woodmizer came and done on our mills and other people's mills, they're trying to see what kind of load you're putting on the motor. And from all the data that Woodmizer's told me, nobody is loading these motors extremely hard. Matter of fact, I was the highest loaded mill that they tested. And I'm not trying to, say anything by that. I'm just saying, I feel like I know a thing or two about making these mills cut right and really produce lumber. That's the only reason I'm telling you this. So let's say you're not, you're sawing and you're not getting any bog on your motor. And what I mean by bog is, the motor is pulling down. Like the RPM, you're going through the log and you're pushing it extremely hard, and the motor isn't bogging when you're going through it, but the belt is squilling. That means that you're not getting proper tension on your belt. And let's say that you have adjusted the belt tensioner, which I'm going to go out here and show you guys. So on these Super 70s, this is your belt tensioner. Basically, you loosen this nut here, and then you run this in or out. You run it out, which would be this way, and it will make this pulley go up and push tension on this belt whenever you hit the throttle. And you've got a button in there. All mills have a blade or belt tensioning system on them. Now, I had mine properly tensioned, everything set, and it still would not go through this, these logs like I was used to. And this started about a week ago and started giving me trouble. So I got to watching this motor when I would saw, and I noticed that when the pulley would come up, and let me go in here and kick it on, I'll show you guys. So watch the back of that motor. I'm gonna kick the blade on. Look right under that pulley. See that go up? All right, let's go out here and I'll show you what I'm talking about. So you can see here, this is kicked up now, and this is putting tension on there. So what I was having is, like I said, I was getting belt squealing problems. And when I was watching this was almost touching this pulley. These were so close. And I would watch this motor and it would shift up. Now this has 12,000 some hours on it. So I got to watching these two rubber, pieces here for the motor to not vibrate and keeps it on there. This one had shifted in like a quarter of an inch just over time. And what I was having to do is run this further and further and further out until it got to the point to where it I noticed it was almost going to fall off the thread. So you guys make sure that you're checking your, and I could see where it was originally sitting at. I could see right here, there was a line, and this was in, like I said, almost 1/4 of an inch. Just over time, the motor had shifted and moved in. So I loosened those, tightened it up, and I'm gonna show you what I mean by it running to where you can hear the motor pull down in comparison. And you can see here, I've got a decent amount of leverage between these two. Now our 22, when we first got it, was the exact same way, and we had to move the motor over. So that's something that you guys will want to watch just to make sure you're getting proper tension. So this is an oak log, and I've put a re-sharp blade on. Some of these have been breaking, but I just want to show you guys and see if you can actually hear the motor bogging. I'm gonna take it out of my ears. I've got my AirPods in. Let me get this set up here. Now any of these that's got these big goofy knots on them, you may have to slow down in them knots. See that one on the left? Hear that motor? Try to listen to it when I get close to the end. I'm pushing it pretty hard. I mean, I'm making that thing sail through there. I don't know if you can hear it in video or not, but a lot of you guys, if you're cutting oak, put a block on there that's 7 to 8 inches wide and see if you can go through it as fast as I can without your belt squealing. Like I said, if you're getting belt squeal, you're losing RPM, you're losing all kinds of stuff, and you're never gonna be able to cut near as fast as your mill should cut. And I've said this before, but 90% of the people that I talk to that can't get their mill to cut right, it's because they don't have proper belt tension on the actual, it's either the motor's too close over, or they don't have a good drive belt, or they're just anything to do with the drive belt. That's like the main heart of these mills connection. It's kind of like the whole driving assembly on them. So if you don't have proper tension, a good belt without a bunch of hairline cracks in it, the list goes on, then you're not going to be able to cut. This is 10 1/4 inches wide, It is just a poplar log, but it's dry. But I'll give you guys an idea of how fast I can go through it. Just line speed. See what you think. And there's a huge knot in there, so keep that in mind. Hear it bogging? But I'm also not getting a big fat lip on my boards at the end. So that means it's keeping consistent RPM throughout the whole cut. It's not losing the momentum and my belt isn't slipping. If you're cutting really fast and you get to the end of the board and the one above it is thinner than the one on the bottom, it's because your blade is losing tip speed as you're going down through there, and so you're not getting all the power into it, and that blade is starting to rise the faster you get through that log. And if you watch, the end of my boards are consistent because I'm keeping the same blade tip speed throughout the whole log.